Hello everyone. Today we're going to talk about lesson 11-2, the area of regular polygons. We'll talk more about the area of regular polygons tomorrow. All right, the question for this lesson mainly focuses on how do we find the area of regular polygons. All right, tomorrow we will also talk about what are known as composite figures. All right, before we get to area though, a couple of vocabulary things that we're going to need to know. All right, first off, just a reminder, a regular polygon is a polygon with all congruent sides and all congruent interior angles, meaning that all the angles have the same measure and all the sides are the same length. All right, new stuff today. All right, point P. All right, we say point P is the center. All right, it won't always be P, but it could be any point there in the middle. All right, P is the center. In this case, it's of this hexagon. Hexagon because it has 6 sides. All right, now from the center we have a couple of other measurements. All right, the first one we're going to talk about is the radius of a regular polygon. Very similar to a circle, the radius starts in the center of our polygon, so it goes from P, and from P it goes to one of our vertices. So I could draw a line segment from P to E. I could draw a segment from P to D. All right, both of those segments would be a radius of that polygon or that hexagon. So my radii would be PE and PD. All right, you could also do one for all the rest of your vertices. So my definition here is a segment from the center of a polygon to one of the vertices or one of the corners. All right, for example, that could be PE or PD. All right, now any of the radii of a regular polygon form what we call a central angle. All right, a central angle is an angle formed by 2 radii of a polygon. All right, in a circle, it would be an angle formed by 2 radii of that circle. All right, in this case, all right, this could refer to angle EPD. All right, it could also be DPC if we drew the radii from P to C, or any of those other radii that we could draw in there. All right, the last measurement we have to talk about is the apothem. All right, the apothem is a perpendicular segment from the center of a polygon to one of its sides. All right, perpendicular means 90-degree angle, as we've talked about several other times in class. So if I wanted to draw an apothem, I would start from P in the center. I could draw a straight line out to DC, where this needs to make a right angle. And I'm going to call that point G. So PG, right, would be an apothem of that hexagon. All right, it doesn't matter what side it goes to, so long as it is from the center and it is perpendicular. All right, so those are a couple vocabulary words. We will talk and use those more tomorrow. All right, so first example, we got 2 types of examples that we're going to do today. All right, the first type is finding the central angle of a regular polygon. All right, so since those angles would go all the way around in a circle, if we put them all together, right, the total measurement there is going to be 360, just like an exterior angle. All right, so if we have a regular quadrilateral or a square, all right, because a square is just a regular quadrilateral, all right, we could draw any 2 radii. We want that point there in the center. All right, if we draw all 4 of them, right? Notice for a square, it looks like it's the diagonals, all right? So I know the total distance around is 360 degrees, right? A square has 4 central angles, so I would do 360 divided by 4. If I do that, I get 90 degrees, all right? Now, for the hexagon up top, there would be 6 central angles, so I would take 360 and divide it by 6. All right, you're basically dividing by the number of sides in each regular polygon. So in a quadrilateral, it would be divided by 4. For a hexagon, it would be divided by 6. For an octagon, it would be divided by 8, so on and so forth. All right, so that is how you find a central angle. That will be the first 6 practice problems that you are doing on your practice assignment for today. All right. The second thing we're going to talk about today is the area of a regular polygon. All right. My formula for the area of a regular polygon, and this is going to look kind of confusing, so we're going to sit here and explain it, right? But it's area equals either 1/2, all right, ANS, all right, where the lowercase a stands for apothem. N is the number of sides, all right, just like when we did n minus 2 times 180. And then S is the side length. All right, we will talk a little bit more where this formula comes from tomorrow. Basically, it comes from splitting your shape into each of the triangles. So if you go back and look up at the square, all right, when we drew the central angles, we had 4 triangles. So it would basically be adding the area of all 4 triangles. That's why we would multiply by the number of sides. All right. The other way you might see this formula is you might say it as A equals 1/2 AP. Right, where A is still the apothem, right, and P is the perimeter. All right, so depending on the formula sheet you see or who you ask, you might see either of those formulas. All right, I will generally tend to use the first one, all right, because the perimeter of a regular polygon is just the number of sides times the length of one side. So you could use either one of those formulas, whichever one makes more sense to you. As I said, I will tend to use the first one. All right, and we're going to do one quick example with that before we're done with the notes for today. All right, it tells me that this is a regular hexagon. So I know my area formula is going to be A equals 1/2 apothem times the number of sides times the side length. All right, since it's a hexagon, that means N is 6. Because there's 6 sides. The length of one side is 30 meters. And the apothem is that line from the middle to a side, which is 26 meters. All right, so then all I have to do is plug that in. I would do 1/2 times 26 times 6 times 30. All right, I would then just go to my calculator and type that in. All right, whether you want to do 0.5 times that or multiply it all together and then divide by 2, all right, it doesn't matter either way, kind of like we did with a triangle or trapezoid. And when we multiply that all together for the area, we would get 2,340. Once again, as we've been talking about, our label there would be meters squared. All right, so it's just finding those measurements, very similar to a trapezoid, parallelogram, kite, rhombus, square, rectangle, triangle, circle, like we've already done. All right, just a little bit of a different formula for regular polygons. So that's it for our notes for today. All right, as I said, you have a practice assignment that is using 6 questions where you have to find the central angle, and then 6 questions like this one where you have to find the area of the regular polygon. So if you guys have questions, I'll answer them tomorrow. All right, just write them down somewhere so that way you remember to ask them tomorrow. All right, once you're done with those 12 questions, feel free to work on either Alex or other missing assignments. All right, have a great day.